So today we're going to learn how to solve by factoring. So last class we factored, and we're going to do the same thing this class, except now we're going to take each factor and set it equal to 0. So if we look at these polynomials, we want to factor the first one. We have to group it, since there's 4 terms, take out the GCF, so that's x squared, and we're left with x plus 3. And then we take out the GCF from negative x minus 3, which is negative 1, and we're left with x plus 3. Okay, so we put the outside terms together, x squared minus 1, and x plus 3 goes as 1. The x squared minus 1, we can break into x plus 1 and x minus 1, since it's difference of squares, and then x plus 3. So we're going to take this and we're now going to set it equal to 0. So we're going to set each of these factors to 0. So if I set x plus 1 equal to 0, I end up with x equals negative 1. If I do x minus 1 equals 0, I end up with x equals positive 1. And if I do x plus 3 equals 0, I end up with x equals negative 3. So now I have 3 answers. Okay, so second one. And before we can do the second one, we have to make sure that we combine any like terms together. So the 2x squared and the 7x squared can combine. So that's going to give me x cubed plus 9x squared plus 14x. So I'm going to take out the GCF, which is x. I'm left with x squared plus 9x plus 14. And now we have a regular quadratic that we can factor. So it multiplies to 14 and adds to 9. We're going to use 7 and 2. So x plus 7, x plus 2. And now we're going to equal it to 0. So we brought the x down that we had on the outside. It comes down, and it's part of our answer. So now we're going to set each of those equal to 0. So the first one is just x. If I set x equal to 0, I get x equals 0. If I set x plus 7 equal to 0, I get x equals negative 7. And if I set x plus 2 equal to 0, I get x equals negative 2. So we get 3 answers from there. Okay, so if we look at the last one, it was x cubed minus 64. So we have to factor this. This is difference of cubes. So we need to rewrite this. So we have x cubed minus 4 cubed. And then we're going to plug it into difference of cubes. So remember, difference of cubes is this. So instead of a and b, we're using x and 4. So we're going to have x minus 4 times x squared plus 4x plus 16. So we want to now set this equal to 0. Now when we factored this, I had said that we can't factor that quadratic any further. It's never going to be able to be factored. So we can't factor it to solve it. So x minus 4 we can set to 0, and we get 4. But for this one, if we set it to 0, we can't factor it. So that means that we need to use the quadratic formula. So x equals negative b, so negative 4 plus or minus the square root of b squared minus 4ac all over 2a. So when we solve this, we're going to get the square root of 16 minus 64 over 2. So negative 4 plus or minus the square root of negative 48 over 2. When you have sum or difference of cubes, you're always going to end up with an imaginary solution for that. So if it's asking us to solve, we can solve for the imaginaries. If it's a graphing question, which we will get to in a little bit later, you can't graph it since it's imaginary. But for now, we're just going to solve them. So I can now break down the negative 48. So think about 48. We have 6 times 8, 3 times 2, 4 times 2, 2 times 2. So remember, we can't use anything that has a branch coming from it. So we have a pair of 2's, and we have another pair of 2's. So the negative 4 is staying there. Now the negative 48 in the radical, we're going to take out the 4 because a 2 is coming from here and a 2 is coming from here. So that's 4 on the outside. And because it's a negative, we're going to take out the I. And then we have a 3 left over, all over 2. So we can now simplify and divide everything by 2. So we have negative 2 plus or minus 2I radical 3. So this one has 3 answers. We have 2 from the quadratic formula, and then we have x equals 4 from the first part. Okay, so if we look at the last one on here. Okay, so the first 2, again, you're just going to factor like you normally would and set your factors to 0. On the last one, if we factor this, so I'm going to group it and take out the common factor, so x squared is going to come out, and we're left with x plus 2. Take out the negative 4, we're left with x plus 2. Smush it together, so x squared minus 4, x plus 2. The x squared minus 4 we can rewrite as x plus 2 and x minus 2, because it's difference of squares. And then we have x plus 2. Set it to 0. So now when we set these to 0, if I set x plus 2 to 0, I get x equals negative 2. If I set x minus 2 to 0, I get x equals positive 2. And then I have an x plus 2 again. So when I set this to 0, I get another negative 2. When you have 2 of the same answer, we're only going to count it once. But what this is called is it's called a multiplicity. And we are going to talk about this later when we do graphing. But the way you would write your answer for this is you would say x equals negative 2 of multiplicity 2. That just means that negative 2 appears 2 times. So negative 2 of multiplicity 2, and we also have x equals 2. So when you're writing this, you don't need to write the entire word multiplicity if you don't want to. Another way you could write this is just x equals negative 2 of mult 2. That just means of multiplicity 2. Anytime we have something that appears twice, we're going to write that answer once, and we're going to say it's of multiplicity 2. So if all 3 of these answers were negative 2, we would say it's negative 2 of multiplicity 3. So multiplicity just means how many times the answer appears. Okay, so to try another example, we're going to look at the second problem here. So we're going to focus on this one. So first we want to factor. So they all have an x in common. So I'm going to take out the x, and I'm left with 5x squared minus 12x plus 4 equals 0. Okay, so now that quadratic is one where a is not 1. So we have to do it the long way. So let's up here work on this. So 5x squared minus 12x plus 4 equals 0. So my a times c is going to be 20, and my b is going to be negative 12. So 2 numbers that multiply to 20 and add to negative 12, I'm going to use negative 2 and negative 10, or negative 10, negative 2. So remember, the first term comes down, so 5x squared. The last term comes down, so plus 4. Rewrite the middle term using the 2 numbers that we found. So instead of negative 12x, I'm expanding that to be negative 10x minus 2x. Once we have 4 terms, we're going to group them and take out the GCF. So I'll take out a 5x here, and left with x minus 2. Take out a negative 2, left with x minus 2. And the parentheses are the same, so we're going to take the 2 outside terms and put them together. 5x minus 2 and x minus 2. So now let's put it all back. We have x, we have 5x minus 2, and we have x minus 2 equals 0. Set this to 0, x equals 0. Set this to 0, 5x equals 2, x equals 2/5. Set this to 0, x minus 2 equals 0, x equals 2. Okay, so let's look at this last one again. So we'll look at the bottom one. Before you can solve anything, just like with quadratics, you have to set it equal to 0. So we have to move the 6x cubed by subtracting it. And make sure you put it in standard form. So I'm going to get rid of that. I'm just going to put this up. So 3x to the 4th goes first. Then I have minus 6x cubed. And then I have 12x squared equals 0. Once it's set up, we're going to take out the common factor. So we're going to take out x squared. Oops. 3x squared. So we're left with x squared minus 2x plus 4 equals 0. So I can solve this right away. 3x squared equals 0. If I want to solve this, I divide by 3 on both sides. X squared equals 0. Take the square root. And when I take the square root of 0, I get plus or minus 0. But that's still the same answer. So I really get 2 answers here. I get x equals 0, but it's of multiplicity 2, because there's 2 zeros that I'm getting from there, a positive 0 and a negative 0. The other piece, x squared minus 2x plus 4, we can't factor that. Nothing multiplies to 4 and adds to negative 2, so we're going to have to use the quadratic formula. So we're going to do negative b, which is 2, plus or minus the square root of b squared. So negative 2 squared is 4. Minus 4 times a times c, which is 1 times 4, all over 2. So 2 plus or minus the square root of 4 minus 16, so I get negative 12 over 2. I'm going to break down my negative 12. So 12 is 2 square root of 3, and then I'm taking out the I as well. So 2I radical 3 over 2. And then everything can be divided by 2. So 1 plus or minus I radical 3. Okay, so we have 2 answers from the quadratic that we used quadratic formula for, and we also have 2 from the x squared that we took the square root of. Now, if you notice something about all of these problems, is that the number of solutions should match your highest exponent. So since this problem started out as an x to the 4th problem, there should be 4 solutions. So we got 2 zeros, and then the 2 that we got from the quadratic formula. Same is going to hold true for the other problems. If we look back real quick at our other ones, this one was 5x to the 3rd, so there should be 3 answers, and there are 0, 2/5, and 2. If we go back and look at this one, it was x to the 3rd, so again, there should be 3 answers, and there are. Negative 2 of multiplicity 2 counts as 2 answers, and then the other x equals 2 is your 3rd. Okay, again, here, x to the 3rd, so you have x equals 4 as 1 answer, and then you have the 2 from the quadratic formula. And in the original ones we started with, you started with x to the 3rd on the first one, you got 3 answers. The second one, x to the 3rd, you got 3 answers. And so it's going to indicate how many solutions you'll have is the highest exponent.